Hey you guys, so I think in the last video I got cut off, but what I was saying is I'm going to go over with an example of a discrete and a continuous graph, and then move on to the next part of the chapter, understanding relations and functions, which is going to be a little complicated because there are a couple of things you must know from this part of the chapter that's like really important for the rest of algebra and like if you do more math in the future. So right now I'm going to start off with a continuous and a discrete graph, and we're going to find out what is the difference between them. So as you can tell, the first graph is discrete, but the reason why it's discrete is just because the points are not connected together. So this horizontal graph actually does have a bunch of points. They are just connected together, so it is continuous. So this is continuous, but this is discrete. And this is an exponential function, or it could be half of a parabola. We don't know if this side is a parabola as well. But that's all I just wanted to point out. And in this one, it's horizontal, but so that just means that the value of the y value stayed constant the entire time while the x kept moving. Okay, so we are going to go to the new chapter. There's a bunch, so I might have to split it up into 2 different videos just so I can explain it thoroughly because it is quite important. Okay, so the first thing we're going to be talking about is understanding relations. And so in order to do that, we need to be able to understand tables and then the graphs. Okay, so I'm going to make a little table right here of x and y. So the x is students. Hopefully I can fit it. Yeah, I do. Okay, and the y is classrooms. So we're going to do students per classrooms, 40, 45, and 50. 2, 3, 4. Okay, so now all we're going to do is we're going to identify with the domain and ranges. Just think of it, it's simple. Domain is x values. Range, y values. We just list it in a little tiny different way. Like you don't list domain colon blah comma blah comma blah. You list it as domain, or I personally prefer D, and then you put a little bracket, and then I will list 40, 45, 50. You need this bracket for your teacher to understand that you're talking about the domain, because that's just how it's written. Okay, now we're going to set the range. 3, 4. Okay, now we are going to put these into our calculators. So get out your calculators and go to y equals, so turn it on, and then we're going to go to list, which is stat, click edit, so enter, and then in the first column, L1, you are going to put in 40, 45, 50. And in the second column, you're going to put in 2, enter 3, enter 4. Now, what you're going to do is go to y equals, go up to plot 1 and click enter. So you just turned on the plot. Now, all you're going to do is you're going to click graph. But before you, actually, don't click graph. Before you click graph, you're going to click window. And so the window is like a range of, which is the purpose of this little thing right here. So the window is the range for what your x and y values are. So in the x minimum, you're gonna maybe put a 35, and in the x maximum, you are going to put a 55. And then it's going to ask you x scale. That's what SCL means. And I would put 5 if I were you. Okay, same thing, except for the y value. You're just going to put 0 through 5, and you're going to put the y scale as a 1. You don't need to touch any of the things below, the x res, the delta x, and the trace step. We don't need to worry about that right now. But for now, we're going to just graph these, and then I'm going to draw the graph I see. So you got to label your x's and y's correctly, or else it won't work. I don't know what's going on. Okay. 10, 20, 30, 40, 50. 1, 2, 3, 4, 5. So we're starting off at 40 at a 2. This is a little slanted, I'm realizing. You're going to 45 at a 3 and 50 at a 4. So now that we have this graph, we are going to now be putting in these input and output relationships, which sound complicated, but trust me, it's not that bad. Okay, I'm going to delete this domain and range as well. Okay, so what we're going to do for this is students classroom. I'll just put class. You are going to make a little rectangle right here. Another rectangle. 40, 45, 50. 2, 3, 4. Arrows of which value is going where. And that's it. This is how you identify the input for 40 is the output of 2. The input for 45, output of 3. Input 50, output 4. So the input is the domain, and the output is the range. That's it. It's simple. It's not as complicated. Yes. Okay, cool. Now, we're going to do the same thing, but we're going to do it in terms of a vertical line test. So what a vertical line test is it's a function that it allows you, it tells you if a function is able to be on a graph relationship. So the actual definition is the vertical line test states that a relation is a function if and only if a vertical line test does not pass through more than one point on a graph of a relation. So yes, it sounds complicated. It's not that bad. So I'm going to go on with, oops, sorry, 1 second. Okay, one example, 2 examples actually, to prove to you what is a vertical line test and what fails it. So we're going to draw a parabola here. I'm going to draw one like that. So vertical line tests are lines vertically, obviously, because it says it in the name. So we're going to draw some lines. Okay, so when you are drawing these lines, you need to make sure if and only if these lines only pass through one point during the curve, the line, whatever part of the graph. It can only pass one point to prove that it is a function. So as you can tell, this line is passing only through one point, only through one point, only through one point, one point, one point. So this is a pass, but for this, passing through 2, 2, 2, 2. So it's a fail. So this is not a function that passes the vertical line test. Okay? So this is vertical line test. It's a little complicated, but I feel like we do use it a little often during other types of math. So I would prefer to know it. Okay. The next thing we're going to talk about, I'm sorry, I'm going through this really fast. I'm going to do this super big review for the next video. So yeah, okay. So the next thing we're going to talk about is we're going to do, so there's a lot of questions that say state, domain, and range, state relation, state vertical line test. So there is a couple of things like that, and it is a little complicated, but I promise you'll get through it. So right now we are given a bunch of coordinates. 13, 33, 17, 25, 22, 22, 25, 17, oops, there, 33, 17. Now, we're going to put them into those little weird rectangles that I was talking about earlier. So, this is X and this is Y. So, hopefully by now you can identify which is X and Y. The first values are the X, the second values are the Y values. So, now what we're going to do, put them into the little rectangles. Okay, so first we're going to start off with 13. Hopefully all of these numbers fit. If not, I will work on it. 25. Yay, fit. Okay. And, okay, the thing I have to point out here is, as you can tell, as we're coming towards the end of this Y list, there are two Y values that are the absolute same. Sorry, that has to have in parentheses. 17 and 17. You write 17 once. Now, all you're going to do is you're going to put them lines. Okay, this is a function. This is a true function, because even if you graph these at whatever plots, it will pass the vertical line test. It'll pass it automatically. But I'm going to show you another example where something will happen. Okay, it's not even, I don't know. I'm not super interested in vertical line tests, but if you are, honestly, good job, because I'm surprised. But I actually was not a super math person. Anyways. Okay, cool. These are the numbers. Same thing, X, Y. Okay, so there's a 1. There's a 5 2 times, so we're just going to leave the 5 as one value. 7 and 11 2 times. Now on this side, there is a 2, a 4, a 6, and an 8. So all we're going to do now, similar process, except we're going to first draw lines. So this 5 goes to this 2, this 5 goes to this 4, 7 goes to this 6, 11 goes to, 6 and 8. As you can tell, one X value is going to literally two numbers. Two Y values are going to one X value right here. So, and same here. So that's what I wanted to highlight, talk about it. The issue with this is it does not pass the vertical line test, because when you graph this, it will be a function where there will be about 2 points in one vertical line. 2 points, which is the issue. So this is why this is deemed not a function, sadly. So that is what I wanted to get for y'all, and I hope y'all understand that. In the next video, I'm still going to go with this chapter because this chapter is a little long. I'm going to go over a bunch of this stuff again. So I'll see y'all next time. Thank you so much for watching.